Okay, so in this problem, it's another projectile motion problem combined with rotational kinematics. You have a quarterback throws a pass that's a perfect spiral. Well, footballs are going to move through the air following projectile motion. So we're going to have like a parabolic shape to the football's path. And while it's moving through the air translationally, while its center of mass is moving through space, it's also rotating. So again, I'm going to use the time from either the rotational kinematics information or the projectile motion information to solve the other part. Now, in this problem, the final question is how many revolutions has the ball made? So my guess is that means I'm going to solve this. I'm going to first do like I did the last problem, solve the projectile motion problem to get the time. And then I'll be able to solve part B, which is going to be very similar to the last problem, other than the projectile motion part is not a projectile launched horizontally, but a projectile launched at an angle above the horizontal. So I'm just going to draw that. I'm going to have that there is my direction that the football is thrown at because it says 55 degrees. So I have an x component and I have a y component. And the angle in the problem is given as 55 degrees. The x and the y are always perpendicular to each other. So my VO in this problem is 19 meters per second. Now, again, like the last problem, usually the best way to get the time, you usually get the time from your vertical facts, not your horizontal facts. And so if I list my facts here, if I list my facts, then VOY, I'll be able to get the original velocity in the y direction from the VO and what trig function, sine or cosine. VO times what? Times the sine. So actually, since I wrote, let me label these here. This is my VOX. This is my VOY. And I'm going to rewrite this because if I'm doing my facts in blue, I want to be consistent. So VOY is going to be VO times the sine of the angle. So that's going to be 19 meters per second times the sine of 55 degrees. And what do you get for that? 15.56. So that would be 15.6 if I round off. So there's my VOY. What other facts do I know vertically? SY. Well, I don't know SY, do I? Okay, yeah, you could do that. So I could say SY is 0 for the whole trip, right? So that's one way of doing it. Okay, I'll put it down. So if we're doing the whole trip, then we do know SY, it's 0. I usually don't use that. I mean, that's not usually the direction I go, but you're right. SY is 0 if it starts and ends at the same point. What other facts do we know? Vertically. AY. So AY is negative 9.8 meters per second squared. And actually, we know VFY? VFY is going to be the negative of VOY. Because if it has a velocity of whatever this is on the way up, then on the way down it's going to have the same magnitude but opposite direction. So VFY would be negative 15.6 meters per second. And then we're solving for time. Now, another option that I could have used is I could have used my final velocity in the y direction as 0 and finished the motion when it reaches its high point. But what I'd have to remember if I do that is I'd have to remember to double my time. because that's the time to get up to the maximum height, and then it would take the same time to come back down. So that's another way of doing it. That's usually the way that I would go. I would go in that direction, and the reason for that is it makes something 0 that's easy to cancel out of the problem. I rarely use this, but the thing is, we now know everything, which means we have more than one choice for how to solve for time. So, since I usually don't use it, I guess I'll use it now. So I'm going to use as my facts, I'm going to use, let's use this as a fact, that as a fact, and that as a fact. All right? Because I usually don't use those, so let's try it with a formula different than what I would normally use. So if those are my facts, then the only fact I'm not using is the final velocity in the y direction. So if that's the case, then my step 2 is going to be Sy equals Voyt plus 1/2 Ay t squared. And since Sy is 0, I can cancel it out. If it wasn't 0, I wouldn't want to use this. I wouldn't want to use these facts because it would require the quadratic formula. But one thing I can also do is if I divide through by t, I'll put a different color here so you can see it, that t will cancel out, and one of the t's there will cancel out. All right? Because if I divide through by t, and every term has a t in it, I can actually do that. I can divide by t. So what I'm going to be left with is that's the only term that has a t. My next step, I'll do the algebra out because I rarely use this, use this combination of facts. So I would get 0. Whoops. I would get 0 equals. Now I'm going to multiply through by 2 because it's a fraction. Bless you. So if I multiply through by 2, that's still 0, and that's going to be 2 Voy plus Ayt. And if I solve for t, all I have to do is move this term to the other side by subtracting it away, and then I'll divide by Ay. So the result will be, my step 3 is going to be that t equals minus 2 Voy over Ay. Minus 2 Voy over Ay. Again, there were a whole bunch of other options, but this is just one option. I don't know how many. Who's the one that gave me Sy as 0? Dan, did you give it to me? So did you do it this way? Oh, really? Did you use a different combination of facts? Oh. Okay, because I never used this, but so did you use Sy as one of your facts? Oh. All right, so just a different look at it. So step 4, we're going to have t equals minus 2 Voy over Ay. So Voy was 15.6 meters per second, and Ay is negative 9.8 meters per second squared. So the negatives will cancel out, which they better because you can't have a negative time. And if you solve that, what do you get for your time? Which even if you used a different formula, we should all get the same time at this point. I mean, there's different ways to get there, but what do you get? 3.18. So now that we know the time, we can now figure out how many revolutions the football makes. So now we're going to start the rotational kinematics part of the problem. So we did all that work just to get the time so we would have enough facts to solve for the revolutions. So step 1, there's the time that we just got. The unknown is the number of revolutions. So again, we're in revs. The ball is spinning, is rotating. The ball spins at 7.7 revs per second. So now, it's not saying that it started from 0 and then it reached that. We're just saying that that's the speed, that's the constant speed it's moving at. So I'm going to call it the original, 7.7 revs per second, and then say that if it doesn't change, then alpha is 0. And again, to keep it consistent with the units I have above, I'm going to write that as revs per second squared. So what I'm doing now is identical to the last problem. Those are the facts. Step 2 is theta equals omega original t plus 1/2 alpha t squared. That's all 0. So there's no algebra to do. So just plug in the numbers. Theta equals omega original times t. So that's going to be 7.7 revs per second times 3.18 seconds. And that comes out to be what? 20 something, right? 24.5 revs.